Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 521. In this episode, Scott talks with Lyza Gardner, CTO of Cloud Four, about her recent explorations into hardware using the Johnny 5 framework.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Lyza Gardner. She's the CTO of Cloud Four, and I recently attended a class that she gave at a meetup with my 8-year-old, and we learned how to talk to hardware with Johnny 5, a JavaScript framework. Thanks for chatting with me today.
Oh, thanks for having me.
Yeah, so I just went to this meetup and that you were speaking at, and I took my 8-year-old. We had a blast. He is super excited about doing JavaScript now, more than before, because I think it entered the physical world. Now it's not just drawing circles on Khan Academy anymore.
Right. You can actually have impact on things that exist in physical space.
Yeah, I've walked him through the Khan Academy basics of JavaScript. He's drawn a snowman and things like that. But, I think that for teaching kids, the physicality of it is more compelling than the abstract, circles and fills.
Sure. Yeah.
You've been a web person for a long time. I think we came up at the same time, 20 years.
About 20 years. Very early web. And I'm absolutely a software person in background. So this hardware tangent has been an exciting change.
Did it take JavaScript to get you into it? Because I know I'd tried with C a couple of times, but never really became a hardware person.
Well, there were two things that got me into it. The first thing was completely by chance. I was speaking at a conference in England called Over the Air, a great little grassroots mobile conference that happens once a year. And after I was done speaking, I decided to enter the hacking contest that they had. The National Museum of Computing in England is located at Bletchley Park, which is where this conference was. And they had a need for some timeline management interface software. So I whipped together a prototype and I ended up winning the hacking contest, which was a great surprise and a great honor. And the gift or the award for doing that was a complete Arduino starter set. And I was traveling, so I had a little bit of time to just sit down and look at it and play with it. And I worked through all of the examples. And this was using the Arduino IDE and writing in the Arduino programming language, which is C-like, and getting through all of those examples. But the second piece was indeed the JavaScript piece. So I went back to my Arduino a few months later and wanted to expand what I understood about hardware and circuitry and hacking in the physical space. And I was Googling one night, and it was during the holiday season a few years ago, and I happened upon Johnny 5. And one of the first things I did was put together a new example for one of the classes that they had, something to do with blinking multiple LEDs or fading out between LEDs. And I went ahead and contributed that example, which was rewarding and got me connected to the Johnny 5 developer community. And then I was hooked from there on out. I think that the JavaScript metaphors in Johnny 5 helped me connect my software background more intuitively to the hardware stuff I was doing. It allowed me to understand things on a higher level as well. The Johnny 5 library wraps a lot of components like LEDs and different kinds of sensors and higher level classes that I can work with. So I don't always have to be in the weeds of configuring pins or doing things with voltages. So the combination of the two is really powerful for me for understanding it.
So I'm looking at the Johnny 5 website. You go johnny-5.io. And a couple of years ago, I had Raquel Velez talk to me about this, and Johnny 5 came out in 2012. But here we are now, 4 years later, and it's really very mature. It has quite an ecosystem built around it.
I definitely would say it is quite mature, and for that reason, I tend to recommend it to people beginning with JavaScript and hardware, because it does have a fairly sizable community constantly banging on it and poking at it. And I also think that it represents a pent-up pressure and interest in the software and web development community for being able to do this and being able to use this kind of tool as a gateway to understanding how to work with hardware. And I think that's really exciting.
So you talk about pins and worrying about the little details of voltage and things like that. This seems like it's the constant tension in getting involved with hardware. Like I go to some frameworks and some boards, and I feel like if I don't have an oscilloscope in my garage, then maybe this isn't for me.
I do think that there's a very fine and hard to chase down line between the hardware concepts, the core fundamentals you do need to know to be proficient, versus being in the weeds, whether that's hardware addressing or voltages, or like you say, feeling like you need an oscilloscope. And I think finding that line is very key. And it's one of the things that I'm spending a lot of time thinking about and wanting to help educate about. Corralling the true circuitry basics. I do think you need to know the relationships in Ohm's law and some things about basic circuitry and the components involved. But what abstraction libraries like Johnny 5 allow you to do is put a little bit of that aside, or put the non-essential stuff aside so you can prototype quickly. Gets out of your way. Now, what you do lose when you have high-level abstractions, of course, is that lower-level control. So there's always a trade-off. But this is how it is, of course, in computer science. You can use this analogy in almost any kind of software development, right?
Yeah, I always use that. I've said it a million times in the show, but I'll say it again, that, each additional layer of abstraction is indistinguishable from magic.
Right.
And, when you showed us the Johnny 5 code, we said, board.on ready. You actually grabbed the ready event. So like right there, we're thinking about eventing, which is just completely foreign. And then you said LED.blink. And I'm like, what? It wasn't voltage on or this pin. It was, it was a very nice high level layer of abstraction. And that, I think, really resonated with my son, because I've been trying to get him into multimeters and stuff. And it's just not as exciting as diving right in and doing something.
Right. It connects language and metaphors that we're more familiar with in our web programming and in our JavaScript programming arsenal. And it does help make us understand. I mean, when you see that there's a Johnny 5 class like LED, and that LED class has a bunch of methods on it, they're what you would kind of expect intuitively if you conceive of what an LED is. You want to turn it off, you want to turn it on, you want to make it blink, you want to make it fade in or fade out, or maybe you want to set it to a different brightness. And even further than that, there's an RGB variant of the LED class that lets you set the color on an RGB LED, and you can use that. You can set that color using, for example, a hex color, which is a very natural way of thinking about colors for web developers, right?
Totally good example. The question I would have then, as someone who, I want to be productive and I want to learn, like you said, the basics, but let's talk about fading, for example.
Sure.
Do I dig into pulse width modulation and then learn all about it and make it so I could write my own fade and then accept that there's a fade, and then, from that point I'll live at the high level of abstraction? Or do I just simply, read a paragraph or two, get a general sense of what pulse width modulation is, which is where I'm at right now?
I think that the latter is probably fine. So if you have a general understanding of how pulse width modulation works, and an understanding of duty cycles, I think that is probably plenty. Do you need to go write an algorithm for pulse width modulation to be able to say that you understand it? I don't think that that's necessarily the case. So I think there are some shortcuts you can take that are not detrimental to your understanding of hardware.
Okay. So that's actually, PWM is actually a really interesting thing we should talk about for a second. So you go from LED.blink, and then you talk about fading. there's different kinds of pins, I understand, and different pins support different things on an Arduino.
Yes, so we're specifically speaking about an Arduino Uno, which is the most popular Arduino development board. But pretty much any Arduino development board you'll get has some pins that are capable of digital input and output, and some of those digital pins will be able to support PWM, not usually all of them. And what a normal digital pin that does not support PWM is either on or it's off, or more specifically, it's high or it's low. What PWM gives you is the ability to alternate between the high and low values on that pin very, very fast and at very specific ratios. So you might have something that's 50% on or off using PWM, using what they call a duty cycle, which is as you look across a period, what's the average amount of time that signal is high versus the amount of time it's low. And that way you can sort of approximate what feels kind of like an analog output because you have something that's on 50% of the time. If over time, the average effect is that is half voltage, or that's how it looks to us in the real world because we can't see things at that frequency, of course. So when it comes to LEDs specifically, a PWM enabled pin will let you set an LED so that it looks like it's 50% bright. You can't do that with a regular digital pin because it's either on or it's off. So anytime you want to fade or do different colors with an RGB LED, you'll need to use one of those pins.
Interesting. Okay, so forgive my ignorance, but is it kind of like you're strobing it like a strobe light, and it is average 50% on, 50% off over this period of time?
Right. So if you look at if you were to look at sort of an oscilloscope sort of output of that, what you would see is up, down, up, down, up, down with, it would stay up for a given amount of time and then come down and stay down. So it would look kind of like teeth, I guess.
Yeah. Is that what they say, like a sawtooth pattern?
Yeah.
Except it
teeth.
doesn't have a point at the top. It's flat teeth.
It's flat teeth or like crenellated, like a castle.
Ooh, good use of crenellated.
You're welcome.
Nicely done. Yeah, you've got the vocab, that intimidating vocab.
Well, I hope it's not intimidating.
No, I mean that in the best way. I was actually talking to my 8-year-old about that because here I am, not 8, and every 3 or 4 days, there's a word that I'll hear that's like tickles the neurons in the back of my brain, where it's like, oh, I haven't heard that word in 15 years, and I don't really know exactly what it means. So I put it on my list of words to look up. And he thinks it's so funny because he just assumes that adults know all words and have them available at all times. So the goal, of course, is to have the correct word for the correct thing available when you need it in your bat belt.
Right. And there's a difference between passive vocabulary and active vocabulary. Like, we understand a lot more words than we have immediately available for us to use in sentences. So
yeah. And I'm working on getting my vocabulary more better.
Your vocabulary is so bad, it's like whatever.
Yeah, it's like a whatever. It's exactly what it's like. It's so descriptive.
Yeah. Anyway.
So there's microcomputers, microcontrollers, and then I've also heard this term SoC, or system on a chip.
Oh, goodness. Let me see if I can do this without confusing the matter even further, because the lines are quite blurry.
Yeah.
So the definition of what makes a microcontroller is that it is a single package that contains a processor, some memory, and some ability to handle I/O, input and output. And that should all be in one package.
Okay.
So in that definition, most microcontrollers, I believe, can also be called systems on a chip, because a system on a chip is multiple functionality wrapped in a single package, right? So there's a lot of crossover there. The other thing that's confusing is that a microcontroller meets the criteria of being a microcomputer, because a microcomputer needs a processor, like a system bus and memory, I think.
Right.
And I might have these slightly off. So every microcontroller is in effect a tiny computer as well. And then a microprocessor on its own is just the processor without the I/O and the memory, right? But I don't even know if that's strictly correct in terms of how these microprocessors end up getting packaged. So it becomes very difficult to draw a clean line between what we intuitively kind of feel about development boards like Arduinos with their microcontrollers as being low power hardware that's fairly basic. For example, the Arduino Uno's AtMega microcontroller is an 8-bit microcontroller. So the processor on it processes messages in 8 bits. And we just intuitively know that that's a separate class of computing, as it were, than what is going on with a Raspberry Pi on what is sometimes termed a single board computer. And those are really like shot down motherboards when you get down to it. It has everything on it you would expect from a multi-purpose computer. So also the ability to process input and output with peripherals, perhaps more removable storage and more networking. And so the differences are subtle, but we kind of intuit them. Almost more than academically they are subdivided. So you've got your microcontroller-based boards tend to perform single-purpose tasks. That's what they're made for. They're very robust for that. Whereas with the single-board computers, because they can run OSs, they can do many tasks at once. So they're more multi-purpose, like what we think of as a computer.
Yeah, I appreciate that you point out that there is the actual definition, and then there's what we intuit or what feels natural.
Right.
Because I feel if it has an OS and I can move my mouse around and I can open up something that looks like file management, that's probably a computer. And if it's a tiny computer, then maybe I'll call it a microcomputer. That's certainly not technically, well, it's both technically correct, but it's an overloaded term.
Right. Our terminology actually trips us up because there's simultaneously lay people, for lack of better word, quote unquote, incorrectly using terminology. But then again, the actual accurate terminology is fraught with difficulty too, and over precise, and also in many cases was invented a few decades ago when the entire computing landscape was just completely different.
Right. One of the things that I think is so interesting is that what we now think of and call a microcontroller, like an AtMega, is effectively what I had 25 years ago as my first computer. Like here we have like 16 megahertz frequency CPUs that are, with 128K of memory.
Yeah, 32K on the Arduino's microcontroller.
Yeah, and this is what, like $8?
Well, I think you can get an AtMega 328P, which is the microcontroller on an Uno, for $3 or $4 actually. Well, and if you're at scale, it's considerably cheaper than that.
Yeah,
but, I recently built my own Uno compatible board on a breadboard. So I just bought the microcontroller and the timing chip and a few other bits and bots separately and built it myself. And the actual components, and these are bought individually, so there's no economy of scale. I think were probably $7 or $8. The expensive piece was actually I had to get what's called an FTDI programmer because I didn't have all of the hardware that you get on an Arduino board to make it so you can just plug USB into it. So I had to get one specialty piece of hardware to be able to program it, but that's reusable on any board that I would have. But that did cost $15. So my first board cost me probably $20, $25 to make, but if I made another one, it would be $5 to $8 maybe.
I actually had to take out a loan in like 1989 and buy a computer that was similarly powered, and it was a couple $1,000s.
Yeah,
so,
I have a great memory actually about that. I think in 1989, my mom invested a bunch in buying components from the JDR Microdevices catalog. I don't know if you remember that.
Yeah.
So, and there was an article in PC Magazine. I can find you a copy about me building that at age 10 or 11. Yeah, and it was such a great, and it such a great experience. It was the Intel 8088 processor at that time.
Okay, well, we have to find that and put that in the show notes.
Okay, I think I do have a copy.
That has to be, like, T-shirts need to be made. So you made an Arduino on a breadboard. So that sounds like a fun and intimidating thing to do. Is that something that's hard?
No, not at all. So there's some good tutorials on the internet, blog post style things. It took me maybe an hour and a half, and that was completely just like,
really?
Oh, it was completely just the finicky bits of like cutting the wires to the right lengths and stuff. I mean, it was actually...
Oh, so you made it look nice.
I wouldn't go so far as to say nice, but just so there weren't loops of jumper cables everywhere, jumper wires everywhere. So I think the number of components you actually need is 10 or a dozen, maybe. I mean, there's a couple LEDs you plug in first to see status, and then you need to have, connections to a few things. But the bits are really the microcontroller, the timing chip, and then just some status lights and making sure that you can give it power that's at an appropriate voltage. It's astonishingly simple, because really what you get when you get an Arduino Uno board, what that gives you is actually the ergonomic factor. The form factor is actually a large part of it. It's breaking out. It's providing those pins that you can plug into with wires that wire directly to those corresponding pins on the microcontroller, but it's not actually adding a whole lot of extra functionality. And then it gives you that USB connection, which is handy, and an onboard reset button. I did put a reset button also on my breadboard version. But there's really the advantage of having the developer board and having an Arduino compatible board is that they are of a fixed and specific size and shape. And that way you can extend them with shields and other things that are built at those same dimensions. So that's a large part of what the boards actually give you.
Right. And it looks like, I'm looking at the list here, like the magic or like the hardest part of this or the most advanced part is that USB to serial breakout board. That does the work. That does work for you that would be tedious otherwise.
Yeah. So I use an FTDI one, which I think does plug into my USB port on my computer. And then that just works. I can program it through the Arduino IDE. I haven't actually tried to run Johnny 5 code on that. I haven't flashed it with Fermata, that is, and we can talk about Fermata in a bit, to try that, but I don't see any reason it wouldn't work just like my other Unos, since it does when I use it with the Arduino IDE.
That's a great segue. So after you've built this, whether you buy an Uno or you have, like, I've got about 6 different Arduinos, and they're all different flavors. They're wonderful. They are literally like candy bars, and there's fun size and there's jumbo size. I've got little ones that are the size of my thumb, and I've got big ones that are the size of a deck of cards, right? You have to, they come with like the default just works. They're bootloaded with appropriate thing. The one that you built on a breadboard, you would need to kind of kickstart, right?
I actually bought the microcontroller that I bought came with the bootloader already on it. So that was very helpful.
Oh, okay. That saved you time. Now, this speaks, like you said, a C-like language. So
yes, typically the Arduino workflow is that you use the Arduino IDE software, which does work across platforms, Windows, Mac, Linux. It's free. You download it, you write code in it, and the Arduino programming language does look and feel like C or C++, minus a few types, and also with the addition of a number of built-in functions that are specific to working with the hardware, setting pins high or low, or configuring pins in certain ways. So you write that, what they call a sketch, in the Arduino IDE, and then you compile and upload that to the microcontroller on the board. You plug your board into USB, and it does compile it. So there's a step between. It compiles it into machine code that is understandable by the Atmega controllers, which are an AVR architecture. So it makes it compiles it and then sticks it on the device. And then once it's on the microcontroller and on the board, it is the firmware of the board, which means that it is stored in non-volatile program memory, ROM, as it were. So when the board loses power, that firmware stays there. It doesn't go away as it would if it were in volatile memory like RAM. So there's flash memory on those microcontrollers that these programs sit in. And once they're in firmware, that board is then independent. So you could go plug it in or give it battery power somewhere else, and it would still do its bidding that you uploaded from the Arduino IDE. Now, if you do want to use something like Johnny 5 and use Node to control what's going on the board, it's a different configuration, a different relationship. So what you end up doing is preparing the board so that it can speak in a common API that you can then write code on your computer to speak to it as well. So there's this API that sits between the microcontroller and your JavaScript as it ends up being logic. So what you first need to do is prepare the board to be what's called a client in this host client configuration. The board will become a client and will listen and take instructions. So the way that you get that to work is that instead of uploading a sketch from the Arduino IDE that does a specific thing, like make an LED blink or make some noise, you upload a sketch that represents something called Fermata, which is a protocol that can serve as this common API. It's based on MIDI. And so you open that sketch in the Arduino IDE and you upload it to the board. That sounds a little bit complicated, but fortunately this is common enough that the Arduino IDE comes with the Fermata sketches that you need. So you can just open it within the Arduino IDE. Standard Fermata is where I usually start, and you can then upload that to the board just like any sketch. Once that's there, the Fermata protocol is now in the firmware. All right, so that's step one. You've now made the board the client. Now to program it to do something, you can install the Johnny 5 Node framework, and then you can start writing code in JavaScript for that.
No, back up though.
Sure.
You install the Johnny 5 Node framework on your main laptop on your computer,
or your
not
computer.
on the device.
Correct.
So once you put Fermata on the Arduino, it's now the submissive in this relationship, and its job is to just do what it's told over the. Does it think anymore? I mean, does it?
Well, it thinks in the sense that it's processing input and output from its pins, right? So it's taking that, and with the firmware that it has on board, it's translating those messages into that common protocol. But it's not doing anything on it. It doesn't have any. It has no purpose on its own. It's sitting there waiting to execute what it's told to do at this point.
I see. So its purpose is to pick up the inputs and the outputs and express them back up the chain in this Fermata protocol, and then the brain, the thinking, happens elsewhere.
Primarily, yes. So once you have the Fermata sketch uploaded to the board, you don't work out of the Arduino IDE anymore. So you kind of quit out of that, and then you move into your text editor and you start writing JavaScript code using the Johnny 5 framework and its classes and objects.
So you use whatever editor makes you happy.
Correct.
You use Node, and can I use any Node library at that point?
Well, you would use Johnny 5. So you would install the Johnny 5 Node package.
Right, but if I wanted to bring in other helpful,
you sure could. So that's what, and we come back to that. But that's one of the things that's powerful about this approach. So you write your JavaScript, and then you execute it using Node. With your board plugged in over USB, it's pretty well abstracted, so you don't have to do like configuration or anything. It generally defines your board, and then the instructions are executed on your host computer, your laptop or whatever, and that's communicated constantly to the board back and forth. And then so the board can then do your bidding. Now, the difference between that and the traditional, as it were, Arduino workflow is that because the client is now dependent on the host to tell it what to do, if you were to unplug the board, it would not be independent. That code would sort of go away. So once you plug it back in, it wouldn't start executing that code again because the code actually exists on the host. So for this host client configuration to work, for things to be functioning, the host has to be continually executing the code and communicating that to the client.
Does it, if you pulled the cable out, does it keep doing what you told it, or does it simply stop?
It will freeze in exactly where the last instruction it receives. So say you had a Johnny 5 script that was toggling a bunch of LEDs, turning a red one on and turning a green one on, and you unplugged it. It might be in a state where the green one's on. It might be in a state where the red one's on. It just depends on when you unplugged it. So you might end up with just a permanently on green LED until the board loses power. If the board loses power, it'll stop doing anything. And when you plug it back in, it will do nothing.
Okay. So if I'm going to build something like this, I'm always going to need this. Is that a host client, or what is the server client?
I call it host client, but it's sort of a loose terminology.
If I were going to make a robot, I'm really using the Arduino not as the brain anymore, but as one of my arms. Right.
It's sort of receiving instructions and doing what it's told. And it doesn't have to be over USB, like physically connected. There are different Arduino compatible boards and other boards that have Wi-Fi or Bluetooth capability. So these instructions can be transmitted in different ways, but they do the client does need to be consistently told what to do. The other combination you can use with this setup is, say you have a Raspberry Pi or another single board computer that's robust enough to run an OS and run Node Also, you can run Johnny 5 on that single board computer and use it to control either its own I/O pins or another connected development board like an Arduino. And so that can feel like a more independent setup.
Interesting. So let's just talk about that for just a second, because you said that you can have Johnny 5 and Node running on the Raspberry Pi, and it could control its own GPIO ports, maybe a little bit less stuff going on than an Arduino, or it could control an Arduino itself, and that would be a totally okay thing to do. It's reasonable to have a Raspberry Pi talking to an Arduino.
Right.
That opens things up a lot, because then at that point you can run the whole thing off a cell phone battery or any kind of portable. Like I've got a battery that I use to a backup battery for my cell phone that puts out micro USB 5 volts. That could be a reasonable couple hours power. For
I think that the highest power requirement on any of the Pi models is 4 watts or something. So I think Interesting. So if someone were going to get started, they go to johnny-5.io. And do you think that the Arduino Uno is just like the default? That's the best way to get started? I think it's one of the easiest ways to do it. It's just so ubiquitous and so well supported and so widely used that I think it's a great beginner's device because it doesn't tend to pull any surprises on you, and it's quite compatible with things.
Mm-hmm. What is the SparkFun red board? I've seen that a lot. They're really nice. They have red boards instead of green, and there's a lot of great stuff at SparkFun. Is that a different device? Have you used that?
Gosh, so I know that they have a red board that is a clone of a Proton. I think they also, I can't recall offhand if SparkFun has their own Arduino clones.
That brings up an interesting question, though. Isn't there, do I have to pick a certain Arduino to make sure that I'm supporting open source, or is there some kind of a thing going on there?
All Arduinos should be open source, open hardware, as well as open software. There has been a problem in the past with counterfeit Arduino, which is kind of confusing when you think about it, because like, how can you counterfeit something that's open source? But it comes down to a trademarking thing. I think with Arduino is a trademark. So the actual boards that say Arduino on them and have the little Arduino logo and stuff, those are actually made by Arduino in Italy, except for the counterfeit ones, which aren't, and that's where that comes up. But there are other companies that do produce Arduino compatible boards. They just can't market them as Arduino specifically. So there's a few other names for Arduino boards that aren't exactly Arduinos, but they're not infringing on anything. They just can't use the Arduino trademark.
But if I pick boards that I find as I'm exploring the Johnny 5 website, I'll probably be safe.
Yes. The Johnny 5 website has a whole section on which boards are supported, and of those boards that are supported, what you can do, which features are supported. Certain ones can't do like certain kinds of serial communication or something. So they have these nice tables that show you exactly which boards support what, which is handy.
Yeah, it is pretty fantastic. It is one of the nicest open source websites I've ever seen. And not only does it work, we've talked about Arduino specifically, but there's Particles and Light Blue Bean is a cool one. The Particle Photon, the Intel Galileo.
That's a Bluetooth board, right?
Yeah.
Mm-hmm.
So there's
Bluetooth
lots of... So if you're a maker, you might have one of these lying around. You may not have to buy anything to start using Johnny 5.
Right, correct, yes. It works on a lot of stuff.
So we can get the code from the presentation that you gave up at your GitHub at github.com/LyzaDanger. And you've got a Johnny 5 hardware hacking section with the samples. And would it be okay if I used that if I gave a talk somewhere?
Of course. I think I threw an MIT license in there, so you should be fine.
Yep, with attribution always.
Yeah.
Well, thanks so much for chatting with me today.
For sure. I've had a great time.
This has been another episode of Hansel Minutes, and we'll see you again next week.